Welcome to Special Right Triangles. Today's objective is to justify and apply properties for 45, 45, 90 triangles and for 30, 60, 90 triangles. We can use our knowledge of right triangles and squares to determine what the 45, 45, 90 triangle theorem is. So if I have a square, I know that all the side lengths are going to be the same. So for this example, I'm just going to say these are all x. Now I can cut a diagonal through this square to make a triangle. Now I have a 45, 45, 90 triangle. The diagonal would split these 90-degree angles in half. So now I have a 45, 45, 90 triangle. So I want to give a letter to the side length, so we'll give it the variable y. We can use the Pythagorean theorem to develop a formula for y. So we're going to use the Pythagorean theorem to solve for y. So what we'll do is we'll just square each side, add them together, and equal them to the hypotenuse squared. This is just a Pythagorean theorem right here. So our goal is to solve for y. So we combine our two x squareds, and we have 2x squared equals y squared. Now since our goal is to solve for y, let's isolate y. So to do that, we want to take the square root of each side. When we do that, on the right side we're left with y equals the square root of 2 times the square root of x squared. We simplify this out, and y equals x times the square root of 2. So what this means is anytime that we have a 45, 45, 90 triangle, the legs are always going to be the same, and the hypotenuse is going to be the length of the leg times the square root of 2. So let's use the 45, 45, 90 triangle theorem in these two examples. We want to find the value of x, and we want to give our answer in simplest radical form. So here I have a 45, 45, 90 triangle. So since this is 45 and this is 90, I know this angle has to be 45. Since this is 7, I know this has to be 7. Therefore, this value here, x has to equal the square root of 2 times 7. For part B, since these two legs are the same, I know this has to be a 45, 45, 90 triangle. And if that's the case, I know that this is the hypotenuse. So what I know about the hypotenuse is the hypotenuse has to equal the value of the legs times the square root of 2. Now I'm solving for x, and I know the hypotenuse. So what I can do is just take this value of the hypotenuse, plug it in right here, and solve for x. When I do that, I have 3 equals x times the square root of 2. Now my goal here, remember, is to solve for x. So I isolate x by dividing both sides by square root of 2. Then I'm left with 3 over the square root of 2 equals x. We can't have a radical in the denominator, so multiply both the numerator and the denominator by the square root of 2. When we do that, we're left with 3 square roots of 2 divided by, now I'll multiply these together, which would be the square root of 4, or just 2. In these two practice problems, we're still finding the value of x and want to give our answers in simplest radical form. So these are both 45, 45, 90 triangles. Now I know that this side here is 10 times the square root of 2. This is one of the legs. So since this is 10 times the square root of 2, I know that this side has to be 10 times the square root of 2 as well. But our goal is to solve for x. And once again, we know that the hypotenuse equals the legs times the square root of 2. So in this scenario, the hypotenuse is x. We know the legs are the 10 times the square root of 2 part, and that's being multiplied by square root of 2. So we multiply that out, and we're left with 10 times the square root of 4, which is just 2, which makes this 20. Okay, for the next one, we have our two legs here, which are the same, and we know that the hypotenuse equals the legs times the square root of 2. The hypotenuse is 16, the legs are x, and we're solving for x. So, divide both sides by square root of 2, then we're left with x equals 16 times the square root of 2. We can't have a radical in the denominator, so we'll do x equals 16 divided by the square root of 2 times the square root of 2 over 2. Then we're left with 16 times the square root of 2 over the square root of 4, which is 2. And this can simplify out because we have this 16 and the 2 here. So our final answer is x equals 8 square roots of 2. The next special right triangle that we're going to work with is the 30, 60, 90 triangle. But to start off, we're going to use an equilateral triangle, break it down a little bit, and find the relationship between a 30, 60, 90 triangle. So let's say that each side length was 10. So here we have an equilateral triangle with 3 side lengths of 10. Now, we know that it's an equilateral triangle, and it's also an equiangular triangle. Therefore, all the angle measurements are 60. So what we can do now is we can split this triangle right in half and create a 30, 60, 90 triangle. Now when I do that, this here is going to be my right angle. This here will be my 60-degree angle, and this will be my 30-degree angle. Now I know my hypotenuse is 10, and since I split this bottom base in half, I know this side is 5. So what I want to figure out is, what is x? And for that, once again, we can use the Pythagorean theorem. So I'll do x squared plus 5 squared equals 10 squared. I want to solve for x, so I'll do x squared equals 100 minus 25. Simplify the right side. X squared equals 75. Now I want to get x by itself, so I have to take the square root of each side. So I'll have x equals the square root of 25 times the square root of 3. So x equals 5 times the square root of 3. So let's look at these relationships. We have a short leg, a long leg, and the hypotenuse. So in this example, the shortest leg is 5. So let's just call it x. So the longest leg is 5 times the square root of 3. So the long leg is x times the square root of 3. Now the hypotenuse is 10, which is 2 times 5. So we can say the hypotenuse is 2x. This is the information on how to determine the side lengths of a 30, 60, 90 triangle. So let's use the information from the 30, 60, 90 triangle theorem to find the values of x and y. We want to give our answers in simplest radical form. Okay, for part A, let's see what we know. We know using the 30, 60, 90 triangle theorem we can figure out the hypotenuse, the short leg, and the long leg. So long leg here is opposite of 60, which is y. The short leg is opposite of 30, which is x. And the hypotenuse here is 16. Well, I know the hypotenuse is 2 times the shortest leg. So if the hypotenuse is 16, I know the short leg has to be 8. And then I know the long leg is the shortest leg times the square root of 3. So here are my values for x and y. Okay, same thing for this one. I want to figure out my hypotenuse, my short leg, and my long leg. My short leg here is x, my long leg is 11, and my hypotenuse here is y. So I can't figure out my hypotenuse until I know my short leg. So I know that the long leg equals the short leg times the square root of 3. I know my long leg is 11, so I can use algebra to solve for the short leg. So I have to divide both sides by the square root of 3, and then I'll have the short leg equals 11 divided by the square root of 3. I can't have a radical in the denominator, so I know that my short leg is going to be 11 times the square root of 3 over 3. So this is the value for x. And then I know that the hypotenuse is just 2 times the short leg. So the hypotenuse equals 2 times 11 square root of 3 divided by 3, or 22 times the square root of 3 over 3. So this is the value of y. So long leg is 11. The short leg is 11 times the square root of 3 over 3. And the hypotenuse is 22 times the square root of 3 over 3. And that'll be the end of today's video on special right triangles. Thank you. Take care.